Year 10 Summer Assessment 2020. We are going to work through the questions from the Year 10 Summer Assessment so that you can check through your answers and go through any corrections that you need to address. So question number 1 is just a piece of calculator work and a check on your understanding of rounding to 3 significant figures. Make sure you input this carefully into your calculator. You may need to include brackets here, depending on your calculator, and you get an answer of 14.30316, which rounds to 14.3 to 3 significant figures. Question 2, part A, some indices work here. We're going to simplify this, so it's x to the 4, but instead of writing square root, I'm going to write power half. Now, we know that when we raise a term, which is already raised to a power, to another power, we need to multiply the powers. This is the rule: x to the power a, all to the power b is x to the ab. So this becomes x squared. Now, 3.5 metres squared. What is the area equivalent to this? We need to remember the unit conversion for area here. I want you to imagine a 1 metre by a 1 metre square. Now, in that 1 metre, each side is composed of 100 centimetres. So 1 metre squared is equal to 100 centimetres by 100 centimetres. So that is 10,000 centimetres squared. 1 metre squared is 10,000 centimetres squared. We're dealing with 3.5 metres squared. So 3.5 metres squared is 3.5 multiplied by 10,000. So that comes to 35,000 centimetres squared. So it's this answer here. So this question on trial and improvement, it's got to the point where 1.4 is clearly too small, 1.5 is clearly too large. So what is the next step? We're going to pick B, which is to try x equals 1.45. So you would try a value in between the two that you're in. Just to give you a diagram illustration of this, 1.4 and then 1.5, and then of course 1.45 is in the middle of these. 1.4 gave you a result that was too small. 1.5 gave you a result that was too large, so we now need to check 1.45, which is in the middle of these two values. So we have 4 triangles. Which pair of triangles are congruent? So it's actually triangles A and D, and we have to look for a rule that we can use to justify this. So they've both got a matching side of 8 centimetres. All 4 of the triangles have a side of 8 centimetres, but the side is bound by angles of 25 and 56 in both cases, which isn't true for the other examples. So it's A and D, which are congruent, and the rule is angle, side, angle. Question 5, part A. We're simplifying 12a to the power 4, b to the power 5 over 2a squared b. 12 divided by 2, first of all, gives us 6. A to the 4 divided by a squared, and b to the power of 5 divided by b gives us b to the power 4. Part B, write this number in standard form. I'll do this down here. So we have 6,005,200. So I'm going to have 0 and a 0 here, as we don't have 100,000 or 10,000, but we do have 5,200 in standard form. So that is 6.0052, and then 1, 2, 3, 4, 5, 6, we would need to multiply by 10 to the power of 6 to generate this number. Part C, which of these values of n makes 2.7 times 10 to the n a cubed number? So 2.7 multiplied by 10 to the 0 is 2.7, not a cube number. 2.7 multiplied by 10 to the 1 is 27. So that gives us a cube number. 2.7 multiplied by 10 squared, just checking, gives me 270, not a cube number. And 2.7 multiplied by 10 cubed gives me 2,700, also not a cube number. So the only answer is 1. Now, look at this equation. it's quadratic. You can see x squared is the highest power of x here. And there is a big hint here in the question. Give your answers to 2 decimal places. That means this quadratic equation is not going to factorise. So if we can't factorise, then we have to look at an alternative method of solving this, and we're going to use the quadratic formula. Now you need to make sure you memorise the quadratic formula. X equals minus b plus or minus the square root of b squared minus 4ac, all divided by 2a. Now make sure you state your values of a, b and c very clearly. A is the coefficient of x squared. We've got 1x squared here, so a equals 1. B is the coefficient of x, so you should hopefully be able to see that b equals 8. And then c is the constant term at the end, c is equal to 5. And I also like to always write down b squared, which in this case is 64. Now that's particularly important if b is a negative number, because sometimes people input this into their calculator without thinking through, and they square a negative number and then get a negative result because they haven't used their calculator appropriately. B squared will always be positive. Remember that. Now we have these values, we're going to substitute them into the formula really carefully. Negative 8 plus or minus the square root of 64 minus 4 times 1 multiplied by 5, all divided by 2a, which is just 2. Now, I like to simplify the part underneath the square root sign before we continue. So that's 64 minus 20, which you can do in your calculator, and it's just the square root of 44. And all of this is then over 2. Now, we need to work out both roots, the one where we've got a positive, and of course the one where we've got the subtraction. So starting with the addition first of all, x is equal to minus 8 plus root 44, all divided by 2, and we'll work out what that comes to. It comes to minus 0.6833. Remember, answers to 2dp, so minus 0.68, but notice I wrote down my calculator accuracy and then rounded underneath. Now, the second root will come from x is minus 8 minus root 44 all over 2, and this gives me a value of negative 7.3166 ... So this rounds to negative 7.32 to 2 decimal places, and we have our 2 answers. Question 7 is all about some standard trigonometry in right-angled triangles. So question 7 asks us to calculate the length of QR. Make sure you know which side you're working out. It's this side over here. Now, always label your triangle really carefully. I like to start with the hypotenuse because it's the easiest one to spot. It's always opposite the right angle here. Then we need to label the opposite, which is opposite my 22 degree angle. So there's O, and then we're actually working out the adjacent over here. Now, there are lots of different ways in which people will approach their trigonometrical calculations. As long as you use a method that you are comfortable with, that is absolutely fine. So we need to identify whether we're using sine, cos or tan here. So I like to look at this and identify which 2 sides are we working with. We've been given the hypotenuse and we need to work out the adjacent. So some people will then write down the SO, CA and TOA triangles. And then remember that we're using this triangle over here. Different people will then go about the calculation in different ways. Some people will look at this, identify that they need to work out A, which means they cover up A, and they can say that the adjacent is equal to C multiplied by H, which is cos 22 multiplied by 18.3, which comes to a value of 16.967 and I will round that. The question doesn't actually ask me to round it to a particular degree of accuracy, in which case it's better to do perhaps 3 significant figures or 2 decimal places or 1 decimal place perhaps. So I'm going to say 3 significant figures, 1, 2, 3, which gives me 17.0 to 3 SF in centimetres. Now, other people memorise the trig calculation ratios, so people will actually memorise that cos of the angle is the adjacent divided by the hypotenuse. Cos 22 is equal to adjacent divided by 18.3, and then they rearrange to give A equals 18.3 multiplied by cos 22, which of course is still this value over here. So use the method of trigonometry that you are used to using, that you are comfortable with using, and which will get you the correct answer easily. Now, part 2, we've been asked to work out an angle. So another trigonometrical calculation here, angle Z, which I'm going to call theta, Greek letter theta. Now, let's label the triangle, hypotenuse, opposite, and adjacent. So we're clearly dealing with the opposite, which we know, and the adjacent, which we know. So that tells me that we are working with this triangle over here, TOA or tan. So again, people will do the calculation in different ways. Some people will draw out the triangle, and because we've got O and we've got A, the only thing we can cover up is T. So what does that tell us? That tells us that T equals O over A. But remember, T actually stands for tan of your angle, which equals the opposite, which is 10, divided by the adjacent, which is 3. Look at the triangle to make sure you know what the values are. You can then use the inverse tan button on your calculator, or tan minus 1 button on your calculator, which then gets you to the angle, which is 73.30 or 73.3 degrees to 1 dp. Again, other people will memorise the fact that tan of theta equals the opposite divided by the adjacent, and then they will just do the calculation in exactly the same way as we've done here. So again, use the method that you are comfortable with using. Question 8, some algebraic fraction work. So 8 part A, nice and easy. We need a common denominator here, and the common denominator is obviously going to be 35 as the lowest common denominator for these two fractions. So you might write them out with a common denominator like this. The first one has to be multiplied by 5, so that the denominator becomes 35. And the second one has got to be multiplied by 7, which gives us 21x in the numerator. So this then gives us 5x plus 10 plus 21x, if we expand the numerators, all over 35, and this simplifies to give me 26x plus 10 over 35. Some people like to use a technique that they refer to as cross multiplication. So if this is the question, x plus 2 over 7 plus 3x over 5, they will simply multiply this up here and this here, and then you've got a common denominator as well. So they would go straight to 5x plus 2 plus 7 times 3x, or 21x, all over 35. Remember, different people work questions out differently, and we can get to the same answer with different methods. Now, question 8. We've got to simplify this algebraic fraction. We must factorise. We do not start crossing things out at random. Now, the numerator, we can take out 3, x take 3, in the bracket there, and in the denominator, it's a quadratic. It factorises as x minus 3, x minus 2. And now we have a factor that's common to the numerator and denominator of x minus 3, which then gives me 3 over x minus 2 as my final answer. Question 9, similar triangles. Always look for these key words in questions. Now, which of the following equations is correct for these triangles? So, they all seem to have a 3 plus x in the numerator, so let's link up the matching sides. 3 plus x is going to match up with 4, so we can write 3 plus x over 4. And if we then match up the other sides, it's 9 matching with 5, and they're in the same ratio like that. So the correct answer is this one over here. Now, we can then solve this equation here. Let's multiply both sides by 4. So I get 3 plus x equals 36 over 5. Remember, you're multiplying by 4 over 1, which is why it becomes 36 over 5. Then let's multiply by 5, or 5 over 1, which gives me 5 bracket 3 plus x equals 36. Keep solving. 15 plus 5x equals 36. 5x is equal to 21. And this then gives me x equals 21 over 5, or 4.2. Question 10. We have a cumulative frequency graph, and we need to estimate the median score. Now, to do this, we need to go halfway up the cumulative frequency, which is 30, and then using a ruler, and we must draw this on the graph so our working is clear, we then go halfway through and down to where the median score is, and the median score is 70. Estimate what fraction of the people scored more than 30. So that's interesting, more than 30. Let's find a mark of 30, which is here, and then go across to the cumulative frequency axis. Now, you can see that that coincides with about 15. So 15 people scored, let's say, less than 30. Now, that means 45 people scored more than 30 because the graph goes up to 60 on the cumulative frequency axis. There were 60 people in total. But the question actually says what fraction scored more than 30. So 45 people out of the 60 scored more than 30, and that simplifies to 3/4, which is our final fully simplified answer. Question 11. A little bit of geometry here. The area of the square base is 36 centimetres squared. Now, if this area is 36, the sides must be 6, okay? It's area that's 36, not perimeter. It's area, which means that the two sides must multiply together to give us 36. 6 times 6 is 36. Do not do 36 divided by 4 because you've not been told that the perimeter is 36. It's the area. So now, let's look at one of these triangular faces in a bit more detail. We have a base of 6 and an angle of 70. Now, to calculate the area, we need to work out the height. So what I'm going to do is split the triangular face into half, into two right-angled triangles. Here's my angle of 70, and then the base of the right-angled triangle is obviously 3. And I want to work out this height here, which I'll call x. Let's make sure we've labelled our triangle. So the hypotenuse is over here, this is the opposite, and this is the adjacent. So which two of the three are we interested in? Well, I need to work out this, otherwise I won't know the height of the triangle, and I've been given the adjacent. So I need to use tan. So if you remember, some people like to work with SOHCAHTOA triangles, and in that SOHCAHTOA triangle, what do we know? Well, we know A, we don't know O, we're trying to find it. So if I cover up O, the triangle tells me I need to do T multiplied by A. T, remember, stands for tan of the angle, tan 70 multiplied by 3, and that gives me a height of 8.24248. No, 3. ... Now I need to keep that to as many degrees of accuracy as I can. Do not round this value now. If you use a rounded value later in the calculation, your answer is going to be wrong. Now remember, some people like to do the calculation differently. They like to remember that tan of the angle is the opposite divided by the adjacent. So tan 70 is x divided by 3. and then rearrange that x equals 3 times tan 70. So use whichever method works for you to work out the height. But we know that the height is this value here. So the area of one of these purple triangles is a half multiplied by the full base, which is 6, multiplied by 8.2424 ... You could also work out the area of one of the right angle triangles and double it. So that's 24.727 to ... 24.7 centimetres squared to 3 SF. You're not given a degree of accuracy if you're rounding, so use a sensible degree. Question 12, some iteration here and some poor answers for the first part. Show that this equation has a solution between x equals 0 and x equals 1. Now, if x equals 0, we know that x cubed plus 4x is equal to 0, and this is less than 1. Look at our target. The correct answer, the final answer that works for us, will get to 1. Now, x equals 0 gets us to a value that's less than 1. What happens if x equals 1? We then have x cubed plus 4x, and we substitute in x, and it would give us an answer of 5. Now that's bigger than 1. So remember, the target was 1. When we tried x equals 0, we got an answer that was less than 1. So we were too low. When we tried x equals 1, we got an answer that was greater than 1, so we were too high. So in between x equals 0 and x equals 1, there must be some value that gets us to our target, which is 1, and that is y. And so here's your explanation. It's because one of these is too low and one of these is too high. There must be a value in between them that gets us to the answer. Now, part B, some simple algebra. We've got to do this rearrangement. So the first thing that I'm going to do is say 4x is equal to 1 minus x cubed. I've subtracted x cubed. Then I'm going to divide by 4. X is equal to a quarter minus x cubed over 4. Done. And this then becomes this iterative formula. Now, we've been told to start with x1 equals 0. x2 will be calculated by substituting in x1 into the iterative formula here. So x2 is a quarter minus x1 cubed over 4, which is a quarter minus 0 cubed over 4, which of course is a quarter. To then work out x3, we take x2 and we substitute it into the iteration formula. So we have a quarter minus x2 cubed over 4, and of course x2 is equal to a quarter. So it's a quarter minus, and I'm going to call it 0.25 cubed over 4, and then we work this out, and it comes to 0.246093. And if you have cleverly set your calculator up carefully, you can then keep pressing the answer button to iterate the calculations. So we take this number here and we replace x with that, and this gives us x4, which is 0.246274. You need to make sure you're writing down at least 5 decimal places. And then I'm going to do one more, x5, which is 0.246265, ... And we've been asked to give our answers correct to 3 decimal places. Now, to 3 decimal places, you can see that we have agreement between all of these values. So I'm going to say x is 0.246 to 3 decimal places. Question 13, part A. Find the value of this number here. Well, if you input it into your calculator, you get 2.5 multiplied by 10 to the negative 69. So a patient has a disease. She has 4 cubed body cells affected on day 1. The number of affected cells doubles every day. The disease becomes serious when 2 to the power 10 body cells are affected. On which day does the disease become serious? Now, different people work this out in so many different ways. some people said day 1, there were 4 cubed, which is 64 cells affected. So on day 2, we had 128. Day 3, 256. Day 4, doubling again, we've got 512. And day 5, we've got 1024. And of course, 1024 happens to be 2 to the power of 10. So 5 days. On which day does the disease become serious? Day 5. Now, some people like to do this with a slightly more sophisticated approach, looking at powers. Day 1, there are 4 cubed affected cells, which is 2 squared to the power of 3, which is 2 to the power of 6. So day 2, we'd have 2 to the 6 multiplied by 2 for the doubling, which is 2 to the 7. Day 3 would be 2 to the 8. Day 4, 2 to the 9. And then day 5, you can see you get 2 to the power of 10. So a different way of approaching the question to give us the same answer. Question 14. Can you identify which one of these is an incorrect use of the quadratic formula? Now, 3 are correct and 1 is incorrect. Can you identify which is the wrong one? Now, hopefully you can see straight away it's B, because remember, this part here is meant to be B, and this part here is meant to be B squared. Now here, the B value is -6, and the B squared value is 64, and they just don't match, because -6 all squared would be 36, so it can't be right. Remember the quadratic formula, you've got to learn it. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. Now here, your b value is 8, b squared is 64, so that works. Here, your b value is -2 and b squared is 4, which works. b equals -3 on the last one and b squared equals 9. So all of A, C and D work. It's just B where the formula has not been applied correctly. If this had been 36, it would have been correct. Question 15. So the rectangle is at a scale of 1 to 25. So the perimeter of the original rectangle. Okay, so that means that we need to scale up each of these. So 9.4 needs to be multiplied by 25, which gives us 235. 4.2 needs to multiply by 25, which gives us 105. So the original perimeter would equal 2 lots of 235 plus 2 lots of 105, which comes to 680 centimetres. So you're using the scale of 1 to 25. So 9.4 has got to be scaled up like that, which means you need to multiply by 9.4 to get the new value. Again, if you've got a side of 4.2, look at the ratio. The 4.2 represents a multiplication by 4.2, so you've got to multiply 25 to work out what the new value is. Question 16 is a very standard factorisation. X plus 7, x minus 3, a quadratic factorisation. And it helps in the second question because the numerator here we can now factorise. And we've got an unfactorised denominator with a, b and c as unknowns in there. Now, look at the simplified answer. Can you see that the numerator contains an x minus 3? So that means that the x plus 7 must cancel out with something in the denominator. There's got to be an x plus 7 in the denominator here to cancel out. Now, we also know in the final answer there's a 2x minus 1, which again must have come from this denominator here. So the denominator must be x plus 7 multiplied by 2x minus 1. Check that. Write it out. The numerator we've got like that, it's factorised. The denominator, I think, is x plus 7, 2x minus 1. Now look what happens. X plus 7 cancels, and then you're left with this, which is what we got here. Now, how do we find a, b and c? Well, expand this pair of blue brackets. So we get 2x squared minus x plus 14x minus 7, which is 2x squared plus 13x minus 7. And then can you see your values of a, b and c? So a is 2, b is 13, and c is negative 7. And we should write all that down. A equals 2, b equals 13, c equals negative 7. A logic problem. Question 17. Two groups of people are trying to lose weight. Group A join a gym. Here is the information about their weight loss. And it's a cumulative frequency curve again. So the total number of people in Group A is the highest value of the cumulative frequency, which is 60. Does everyone in Group A lose weight? And explain how you decide. Now, the answer to this is indeed yes. And you can see, because everybody loses at least this value over here, because the graph doesn't start at the origin. So how do we know? The graph starts at 0.8 kilograms on the x-axis. So everyone loses at least 0.8 kilograms. In part B of this question, we need to know the median weight loss for Group A. So I'm actually just going to mark it here on this graph now because it will come up on the next slide. So there's the 30th person, halfway along 60. Scroll down here and the median is equal to 1.2 kilograms, which we'll need in a minute. We're also going to need later on the interquartile range for Group A. So let's find the lower quartile, which is the 15th value, which is approximately here. I'll scroll down to there, and that gives me a value of about 0.9 or maybe 0.95. And my upper quartile is my 45th value out of 60. So if I again scroll all the way down here, that gives me about 2.55. And my interquartile range is the difference between these two values, and that comes to an answer of 1.6 kilograms. We now have information about Group B. Does everyone in Group B lose weight? Now, look at this interesting part of the graph here. The answer is no. Now, the fact that there is a negative weight loss means that some people have gained weight. Now, part C, compare the weight loss of Group A with Group B. Now, there are very neat ways of doing this, which involve thinking about the sensible things to compare. Let's look at the median. So the median loss for B, or Group B, is this value over here, which is 2.5 kilograms. Now, the median loss for Group A, and you may have to go back and read this from your cumulative frequency graph, the median for Group A is, we saw it previously, 1.2 kilograms. So Group B have, on average, a higher weight loss because their median is higher than that of Group A. Now, the second thing that we want to compare is the range, or the interquartile range. Now, let's have a look at the interquartile range for each group. So the interquartile range for Group B is this value here. It's the measurement which takes us from the lower quartile to the upper quartile here. So the lower quartile is 1.5. The upper quartile, so there's the lower quartile, and the upper quartile is equal to 3.1. So the interquartile range for Group B is the difference between these two values, which is 1.6. So that's the spread of the central 50% of the data. So the interquartile range for group B is 1.6 kilograms, and the interquartile range for group A, again, let's go back to the graph to have a look at that. So the interquartile range for group A is also 1.6 kilograms. So both groups have a similar spread or variation of results. So when you're comparing two data sets, you need to compare the median and say what it tells you about the results on average, and you then need to compare the interquartile range, which tells you about the spread or the consistency or the variation of your data. Question 18, a little bit of three-dimensional trigonometry and Pythagoras. Part 1, we're working out the height CD. I'll highlight it in purple. Important to know your right angle triangles here. So let's draw it out. There's D at the top, C, there's the right angle at C, and there's B. There's 6 degrees and 500 meters. And we're working out the side marked in purple, which is DC over here. So let's label the hypotenuse, the opposite and the adjacent. I need to work out the opposite, and I've been given the adjacent, so I need to use tan here. So whichever way you want to do it, either make use of the TOA triangle and cross out O, which is what you're looking for, or set up the fact that tan 6 is equal to the opposite divided by the adjacent, which is 500, but either way you can work out that DC is tan 6 multiplied by 500. So it doesn't matter which method we use. This method here tells you that the opposite is equal to T multiplied by A, which is tan 6 multiplied by 500, and this method also tells you the opposite is tan 6 multiplied by 500. So that gives us a value of 52.552 ... which is 52.6 meters to 3 SF. Part B. Jamil walks in a straight line from A to D, like that. Doesn't look, there we go. And work out the size of angle DAC. So join up A to C, and then you've got a right angle triangle with an angle that's 90 degrees at DCA. Now, we've just worked out that DC, which is the purple line, is 52.5521. Make sure you've got enough accuracy written down to do this calculation accurately. And AC, we don't know the value of, but we do need to work out DAC, so we need this angle here, which I'm going to call X. So the first thing that I'm going to do is I'm going to work out the length AC, which I'll highlight in orange there. And I can do that using Pythagoras theorem and this right angle triangle, which I'm going to outline here, ACB, and I'm going to say that AC squared is 400 squared plus 500 squared, so AC squared comes to a value of 410,000, and AC is the square root of that number. So this value here is the square root of 410,000. Now, let's label up this triangle, the opposite, the hypotenuse and the adjacent. We're clearly using O and A again. So if you're using your SOHCAHTOA triangle, you need to cover up T. And we can then say that tan of the angle X is the opposite divided by the adjacent, which is 52.55 all divided by the square root of 410,000. So that comes to a value of 0.08207. And how are we going to work out x? Well, we're going to use tan minus 1, the inverse tan of this number. And this then gives us our answer of 4.69189 ... or 4.69 degrees to 3 SF. Question 19. Similar objects. Now, the key here is that the length of this box is 16 centimetres and it's being scaled up to create a box which is 80 centimetres. So you need to know what the length scale factor is. So the length scale factor is 80 divided by 16, or 5. 5 times 16 is 80. We're then being asked about area. If the length scale factor is 5, the area scale factor is 5 squared, or 25. Now, the area of this box is 196 centimetres. So the area of the large box will be the area of the small box multiplied by the scaling factor of 25. So 196 multiplied by 25 gives us 4,900 centimetres squared. Now, the key is that this number is less than 5,000 centimetres squared, so yes, it is possible. Question 20. We have some work on algebraic fractions here. So, part A involves solving an equation. First thing I'm going to do is multiply all three parts of this by x minus 3. So the first fraction just becomes 2. The second fraction becomes x minus 3 over x minus 1. And then we have x minus 3 on the right-hand side as well. So all three parts have been multiplied by x minus 3. I'm now going to multiply by x minus 1. So we get 2 bracket x minus 1 plus x minus 3, and on the right hand side we've already got an x minus 3, but we need to multiply by x minus 1 as well. So how do we get rid of the denominators? We multiply by the values in the denominator. Simplify the algebra here. So expand all the brackets. So we get 2x minus 2 plus x minus 3 equals x squared minus 4x plus 3. And we need to rearrange it so we get this quadratic over here. So the left-hand side simplifies to 3x minus 5. And I need to make one side equal to 0, so I'm going to minus 3x and I'm going to add 5. So subtracting 3x gives me, on the right-hand side, x squared minus 7x plus 3. And then adding 5 gives me a 0 on the left, and on the right-hand side it gives me an 8. So there's the result we needed. Solve this equation. Look at the equation, it's quadratic. There is a value of x squared here. So we need to make sure we state our values of a, b and c. So a is equal to 1, b is negative 7, and you can see here I've also written b squared, which is 49, and c is 8. By writing the value of b squared, it will stop you making silly mistakes on your calculator. Now, let's substitute into the quadratic formula. Remember, the formula starts with minus b. b is negative 7, so minus b will be positive 7. Plus or minus the square root of b squared, which is 49, minus 4 times 1 times 8, all over 2. Now, work out this part here, the part underneath the square root sign first. So that's 17. And then split this up so you've got the positive version and the negative version, and then work them through to get to your final answers, which should be 5.56 and 1.14. Question 21. 6 of these rectangles are joined to make this shape. Now the area of the white rectangle in the middle is 1,440 centimetres squared. Work out the area of one of the rectangles. So we know that this is 5x here to here, and this is 5x from here to here. And we know that this portion here is the same as x. So these little portions are x and x. So in total, from here to here, this is 10x, which means if we work out this part from here to here, it's got to be 8x. So the whole thing works out to be 10x. Now, what do we know about this measurement from here to here? Well, it's this. It's 5x. So we know that 5x multiplied by 8x is equal to 1,440. 40x squared is 1,440. Divide by 40, so x squared is equal to 36, and x is equal to 6, square rooting. That's not enough because we have to work out the area of one of the shaded rectangles. So the height is 6, which is x, the width is 5x or 30, so the area of one rectangle is 6 multiplied by 30, 180 centimetres squared.